Hi, my name is Ronelle,
And I'm Allea.
and we're going to be talking about frameshift mutation. So DNA is composed of a series of nucleotides which is transcribed into a RNA and which is translated into protein. Here we have a series of nucleotides that were already transcribed from a DNA molecule. And the first three nucleotides make up a codon, which is read by a ribosome and coded for methionine. The next three code for phenylalanine, next three code for proline, and so on. Frameshift mutation occurs in the DNA strand, where a nucleotide is either inserted or deleted. Here we have an example of frameshift mutation where we inserted adenine somewhere onto the RNA strand. The reading frame is shifted after this point of insertion, which changes the identity of the following amino acids from phenylalanine to isoleucine, from proline to serine, and so on. Here we have an example of another frameshift mutation where we deleted a uracil nucleotide. This deletion shifts the reading frame again to change the series of amino acids after the point of mutation.
So here I have the same RNA sequence that we started with on the other page, and I wanted to show how an addition of two nucleotides actually still changes the reading frame. So the point is that any addition or deletion of nucleotides that isn't a multiple of 3 will actually shift the reading frame. So here it also shifted it and coded for multiple different amino acids. So here I show how an addition of 3 nucleotides doesn't actually change the reading frame. So this was our reading frame for the original, and it continues here. So basically there was only an addition of an entire amino acid. And that's the same that would occur if there was also a deletion of 3 nucleotides. Then basically you would just code for a protein that's missing an entire amino acid, yet the rest of the protein will be the same. It's good to keep in mind that if there is a frameshift mutation that's early in the sequence, as shown here, then most of the protein will actually be coded incorrectly. But let's say that there was a frameshift mutation near the stop codon, near the end of the sequence for that protein, then a majority of the protein will actually be coded correctly, and the protein could possibly be still viable since only the tail end of the protein was actually incorrect. Since a frameshift mutation causes such a dramatic change, could possibly cause such a dramatic change to a protein, then it's possible that it can cause detrimental effects to the organism.